Right, we are starting right now, obviously looking at the numerical methods 2 revision and the couple of exercises which I'll do together. We shall use the fourth order Taylor method with the change in x equals 0.1 to solve the differential equation, this one. Right, so in solving this differential equation, dy dx equals y squared and y at 0 equals 1, right, at the two values of x. So what does it mean to say at the two values of x? Well, normally we estimate at one value of x, but this one is you estimated the first one and then you estimate at the second one. So it's just that you'll get two answers to this. Okay, right, let's get cracking with this. We solve. Right, so solving now, we look at what we need to do. What we need to do, first things first, and that is my advice, is to write down and say we are looking at what we call the Taylor method. Okay, the Taylor method of order n. You can say the Taylor method of order n or Taylor method order n, no matter, yeah, okay. Let me just put off. Taylor method of order n. All right, now, what then do we do with this? Is very popular. We've seen that, and we continue to. All right, now what do we have here? We write the formulas first, and that is the practice, and we're gonna just maintain that. So we're gonna say, for instance, we'll remember that we're gonna say y at 0 is alpha, and then we look at yi plus 1 is actually the same as yi plus, then you have ht to the power n, and then you have xi yi. Okay, now this is the formula we write here, and now this is a variation from the formula we wrote last time for each. Right, for each I equals 0, 1, up to n minus 1. So we have this exactly. So this is the case. And it is true where? Right, it is true where the t to the power n of xi, yi is the same as. Okay, so it's like we're noting our starting time is about 1654. Right, so I'm just noting that, so we can always remember the time at which we need to end our discussion. Right, so you're going to have, for instance, an xi yi plus, then you have h over 2, you have f primed xi yi plus over n factorial. And then you have xi yi. Right, so you need to look at the fact that we make these comments and say Euler's method. This is the November paper of 2023. Euler's method is Taylor's method. Taylor's method of order 1. You said that? All right, Taylor's method of order 1. Now, let's use this here. But what is the exam question 2023 saying, November? It is saying fourth order. So now fourth order, we've seen what we need to do. So we need to get T4 here. So what is T4? Right, so we know that T4 of xi, yi is exactly the same as, so we write this out. So it's xi, yi plus h over 2 if primed of xi, yi plus, okay, now we're going to continue and write the terms, but obviously it's fourth order, so we're going to stop at, okay, this one is nth order. If it's nth order, it stops at n minus 1. So if it's fourth order, it's going to stop at 3. Right, so if it stops at 3, then it will continue here and write the next thing. Okay, if it's out of 2, but yeah, the general formula here is out of n factorial, so it's going to be 3 factorial here. Can write 6 as well. I'm sure you've written that before, and then you have f double primed of xi, yi, like this. Okay, so you have exactly this here. Okay, now this one here must be 2 more, because it is actually obviously always 3 minus 1 up there. Okay, so if you get to this, because obviously we're moving from 1 to the second derivative. So, and if it's n minus 1, so in other words, the order of the derivative is the same as the power of the n, of the h. So the first derivative is h here, second derivative is h squared. Right, but obviously in the denominator, if it's n minus 1, it's only n. So it's like 3 minus 1 is 2, and then it's 3 there. Okay, then we continue. We must go to fourth order. So fourth order, we must stop at 3 here. So we continue to 3, which means f, and then you have 3. X, I, Y, I, and then you divide by, what is fourth order, you stop at 4. Okay, you can write it 24 here, and you can write it 6 there. But we look at the fact that this fourth order formula is correct, because you must memorize this one, because it's not given in the exam. But now looking at the fact that this one here, if they ask Euler or the Taylor, this Euler that is coming, so you have exactly the fourth order, which is going to stop at 4 minus 1, which is 3 over that. Okay, so this is the last term, because it's fourth order. All right, now what do we do next? We just substitute everything into the formula we have. So, moreover, right, we note that the notation we use, like fxy is dy dx y squared, y0 is 1. Okay, so we know these already. Now, which therefore means, therefore, we continue to use this. And what is the meaning of these? Well, we have f, x, I, y, I, these things appear. So this would mean we can do this in this differential equation, and it would exactly be this. Okay. And that means a couple of things that we can substitute into this formula here. Right, let's just substitute into this formula for the fourth order Taylor polynomial. Right. So the fourth order is exactly this one here, is T4. T4 is a derivative, and then you have xi, yi. Okay, which is a tendency that is not there in the module, to explore the formulas a little bit and manipulate them. The tendency is to just quickly substitute. So you have h over 2 into f primed xi, yi plus h squared out of 3 factorial. Okay, even this one you can write 2 factorial, but 2 factorial is just 2. So it doesn't make a difference. This is xi, this is yi, plus h cubed out of 3 out of 4 factorial, and okay, we're repeating this formula. We have already seen this formula on the previous slide. Okay, now having seen this formula, there are a couple of things that we need to do. Wherever there is xi, what do we put? We just put this yi, okay? But so that's what we do precisely. Wherever there is xi, you put yi. So let us just do that. But one thing that is very important, we need to get, because this fxi is already there. Fxi is only yi squared, but we need to get the first derivative, the second, and the third derivatives. So we write the derivatives. So we have that if xy, we write like that, and we say it's dy dx, and this is y squared. Right, let's find the derivatives. We find derivative, which is the first derivative, which is d dx of f xy. Right, so you find the derivative of this. What's the derivative of y squared with respect to x? So it becomes 2y. Then you have dy dx, like so. Okay, now what is this? What is actually dy dx? Okay, dy dx is actually dy dx is fxy, which is y squared. So which means it is 2y cubed. Obviously the observation is therefore that the first derivative is 2y cubed. Let us find the next derivative, f double primed of xy. Okay, because it's the fourth order, we'll stop at the third derivative. So it's going to be ddx of f of xy. Right, so with this said, what is the implication of this? The implication of this would be the derivative now of the, okay, we're differentiating the first one. Right, because this is the second derivative, we must find the derivative of the first one. So the derivative of the first one is this one, which is ddx of 2y cubed, which is 6y squared, like this. Okay, but because it's ddx, you must add the extra dy dx. Okay, what is dy dx? Right, dy dx is y squared. So you can write this one down here and say this is y squared is equal to 6y squared. Okay, and the dy dx is y squared, like this. So the implication, therefore, is that f double primed of xy is the same as what? Is the same as 6y to the fourth power. Okay, so we've got the second derivative. So we need the first derivative, the second, and then we shall stop at the third one. All right, let's look at the third derivative. So what is the third derivative? So we have fxy, which equals dy dx, which is y squared. We know the second one, right? We got it to be 6y to the fourth power. And then now we're gonna look at for the third one. So to get the third derivative, can write f3 in brackets. It becomes the derivative with the second derivative. Okay. Okay, what is the derivative of this one? Here. Right, so yeah, 6y to the fourth power. We differentiate that one. So it's going to be 6 by 4, which is 24y cubed. But because it's ddx, we put the dy dx, 24y cubed. What is dy dx? It is y squared, which is 24y to the fifth power. So this means, therefore, xy is the same as 24y to the fifth power. Okay, we've got all the derivatives now. And obviously, the tendency is, yeah, they get the derivatives in the memos. I'm sure you see those there. Okay, for the Taylor. And then now we just have to substitute everything into this. Right, so which means that t, the fourth order, xi, yi, is actually the same as the following. Right, so xi, yi plus h over 2 f primed, f single prime, okay, a single prime of x I y I, and then plus, okay, we're just going to be doing substitution now, squared here of f double primed of x I y I, like this, out of 3 factorial plus h primed, no, h cubed, out of 4 factorial, and then it is f3 x I y I. So what is t x I y I? Okay, obviously this f x I y I, we already know what it is. It is exactly a yi, this one here. So we just substitute. Right, so it is exactly a yi. So we are good with this one. Is yi squared plus h over 2 into, what is the first derivative? The first derivative is 2y cubed. Got it there, 2y cubed. So we plug this one here and say it is, the first derivative is 2y, but because we have the subscripts, 2y cubed, excuse, right, so 2y cubed, but yeah, we put yi, the subscripts, and then we have h squared out of 3, then we have f double primed. So it's going to be 6y to the fourth power, which is 6yi to the fourth power. Six yi to the fourth power. So now you have this one, 24 y to the fifth power. 24y to the fifth power I. Just put in the subscript because you have x, I, y, I. So that is what we get. Okay, there is a factorial here. So we have 3 factorial there, a 4 factorial. Okay, yeah, this question featured elsewhere. But now we're just focusing on this November 2023 paper. So this one is yi squared, and then 2 cancels 2, giving us h yi. So this one is going to give us exactly h yi cubed plus, okay, these 3 cancels, and then you have h squared yi to the fourth power. Okay, 4 factorial is 24, because 4 factorial is 4 by 3 by 2 by 1, which is 24, which is going to cancel with this, and therefore is h cubed yi to the fifth power. So now what do we do here? We substitute, we take this formula and then we substitute into exactly what we need into the formula there. Right, so using the difference equation associated with the Taylor, right, associated with the Taylor method of order. Okay, the order varies is of order 4 here, so yeah. Okay, yeah, it doesn't matter. Right, so we take this one and we plug it into the formula. What is the formula? The difference equation for the Euler. Right, so would need to substitute, so need to just remember this one now because we're going to use it. We're going to use it to do a couple of things. So you have that yi plus 1 is yi. Okay, I stated this in terms of w's last time, but I'm using the y's now because they're popular in this module and the w's. The textbook uses right. So yeah, the textbook uses what w's, but here we're using the y's. In this module is popular in the memos to use the y's there. And this is for each I0, 1, n minus 1. Okay, so quickly let us get what needs to be done here. So it's substitution. So you're gonna have, as said, I'm just gonna mention here in writing to say order n equals 4, order 4. So if you have order 4, it therefore means that you have yi plus 1 is yi plus t4 ti yi, and then you have yi plus 1 equals yi plus, okay, there's h here. So you have the t4. Okay, we have seen that before. I'm just going to plug it in here because it is, yeah, okay. I'm using the t's and the x's interchangeably, but this question is, here we're dealing with functions of x and y. So you have yi squared plus h yi cubed plus h squared yi to the 4th power plus h cubed yi to the 5th power, and we have that. So now we're good. We're so good. Okay, now with this is the difference equation we're going to use. So always the strategy with all the methods we use here in this module is to first get the difference equation, and once we have the difference equation, then it means that so you have yi plus 1 equals yi plus, okay, we can distribute through with the h. Yes, you can distribute the h, is easier. And then you have hyi squared plus h squared yi cubed plus h cubed yi to the 4th power. Okay, so, and then you have plus h to the 4th power yi to the 5th power, like so. Okay, so we can see exactly what is happening here. Okay, you can see exactly here. If this is 2, this is power 1. This is 3 is 1 less, which is 2. If this is 4, this one is 3, and this is 5, this is power 4. Anyway, it's just a pattern that exists in this particular problem, but it's not the universal approach in the Taylor method. Now, let us solve this exam question. Now, with this exam question, we need to remember a couple of things. What are the things that we need to remember? We're just going to be using this difference equation with H equals, okay, so H is given in this, I wrote it there in the beginning. So I'm just going to write it now because it's there at the beginning, right? With delta, okay, the examiner here decided to use delta x equals 1, but we know delta x is like H from the high school days. In calculus, when they say H tends to 0 in the first principles of differentiation, it means delta x tends to 0. So it depends on the books that are being used, because H is just the difference in two x values. Right, so it's 0.1. So in the exam, they gave this one is 0.1, like so. And then now we have that x is 0.1. Is 0.1, so we have exactly this here, like this. So okay, so now, yeah, it's 0.1. Okay, yeah, x is that, and the two values, so you're going to be using both of them. We're going to get two answers, but first we start with the first one. Right, so this one is 0.1, and then also there's 0.2. Okay, so let's continue and solve this question in detail. Right, so, but there's certain things we know, like we know that y0 is what for this question? Y0 is 1, which is can be written as y at 0 equals 1. It is the initial value given in the it is the initial value given in this question. Right, so now let us see what um is happening here. Okay, now we need to get first y1 because y0 is already there. So we need to get y1. Let's use the difference equation. So to get y1 is going to occur when I equals 0. And then that when I0 is going to produce y0, h y0 squared plus h squared y0 cubed plus h cubed y0 to the fourth power plus h y0 to the fifth power. Okay, so we have this exactly. Okay, we can even use delta x, delta x, delta x there. So now let us see what we're getting. So we're going to get y1, and then y0, we already know is actually a 1. Right, so y0 is actually a 1, because you can see it here. Plus h is 0.1. Right, so y0 is just a 1. And then you have h is 0.1, y0 is a 1 cubed, and then h is 0.1, or we can put delta x as said already here. And then, okay, yeah, this is square here, please. And then here, there's a cube on delta x, or on h. And then the y is, y0 is a 1. Okay. h is h to the fourth power here, which is 0.1 to the fourth power. All right, and then the y0 itself is what? Is 1, fifth power. Right, so we can see that if the power is 2, this is 1 less. If it's 3, it's 2. If 4 is 1 less, 3, etc. So we can see we just have a couple of ways of checking if we made a mistake, we forgot something. Right, so we have therefore y1 equals right, so in the end, what is all these here? Right, so we're going to use a calculator to do this because it's convenient. So, but you shall do it on the other side. So it's y1 is 1, then it's 0.1 until 0.1 to the fourth power. So which means this one is 1 plus 0.1, and then 0.1 squared. plus 0.1, excuse me, until to the fourth power. Okay, then we're just going to use a calculator to find the phase estimate. Right, and then to the third, 0.1 to the fourth, 0.1 to the fifth. Okay, so yeah, so because these times 1 times 1, the ones are not changing anything, but it's 0.1 squared cubed to the fourth power. No, to the fourth power. Okay, so we stop at the fourth power there. Right, so we stop at the fourth power. How many times are there? 1, 2, 3, 4, 5. So I always have a way to check 1, 2, 3, 4, 5 for the 1. So it's okay. Right. Now let's quickly get the calculator. Right. So I need the calculator did not launch it first. I should have launched it because now I need to find it from a little bit far. Right, just one sec. Right, so we're here, and then we are right here back. Okay, so now let us continue and find the answer to this. So if you look at the fact that there's a 1 plus, then there is a 0.1 plus, and then there is a 0.1 squared plus, then there is a 0.1 cubed, and see where we get here is the cube, right? And then there is a 0.1 to the fourth power, 0.1 to the fourth power. So now you have exactly this, which is 0.1 and then 0.1 squared, and then 0.1 squared, and then 0.1 cube. Just checking here the cube and then the fourth power. So everything is well. So is 1 point quadruple 1. Okay, good. So which means therefore here it is exactly y1 is 1.11 quadruple 1 like this. And what is this then? Okay, because we have that x0 is 0, x1, which goes with the y1, is actually at the next step of h, 0.1, with delta x equals h equals 0.1. So with this said, what then does it mean? Well, this is the estimate. So it is telling us that the y1, which is at the first h, is approximately, so it's not exactly this, it's approximately 1, 1 that. Okay, they say the accurate value is seen when you use the exact solution of this differential equation. But here we're using a differential equation, so this is not a very accurate answer. Let's move on to the next step because we must do two of them, 0.1 and 0.2. So to do the 0.2, yes, please. No, okay. Oh, is it? Okay, that's fine, but just like more classing. Get more classing. Oh, uteng, ne? All right, yeah, but just like yeah, get more classing, no. All right, maragia kambuta gana, that's fine. Okay, right. So, okay, see, so yeah. All right, that's fine. Okay, thank you, my dear. Right, so we remember the difference equation now, which is, so we need to use this one to get the next one. But to get the next at 0.2, it is then as the next step delta H. So it's going to be y2 from the difference equation. So let us just use the difference equation. Just 1 second. Right. Right, so we have exactly that. Okay, let's look at the difference equation we've got. It's this one. Right, so I'm just noting it because we just I'll just write it on the next slide, and then we shall just do what? We shall just substitute everything to get the next at 0.1 and then 0.2. So which means that we have the following. Right, so we have yi plus 1, which is equals to yi plus hy squared plus h squared yi cubed plus h cubed yi to the fourth power plus h to the fourth power yi to the fifth power. Okay, this is the difference equation that we got for this problem, and we need to get y2, right, which means that is going to occur when I is 1. So you have hy1 squared plus h squared y1 cubed plus h cubed y1 to the fourth power, h to the fourth power y1 to the fifth power. Okay, right. So which means that at this point, what are we getting? We're getting y2. So we have y1, which is 1 point quadruple 1. So that's what we're going to plug in here. 1 point quadruple 1 plus h is 0.1 for this problem. And then we have 1 point quadruple 1. And then you square it plus 0.1 squared, 1 point quadruple 1. Okay, so you need to cube this one. Plus, now we come to the h cubed, which is 0.1. You cube it. And then you have 1 point quadruple 1. And then you have 0.1 cubed to the fourth power. 1 point quadruple 1 to the fifth power. And then now you have y2. All right, so we got this one, and let's just use the calculator to get the answer. The calculator is all we need in this module to do the problems. So let's just let us get this here. So which means that you have 1 point quadruple 1 plus, then you have 0.1 times 1 point quadruple 1, which is square. Okay, plus, right, you can do it in many ways. I'm just doing accurate thing here, just to get more correct answers, just in case this calculator has its own interpretation of the input. So you have this one here and you square. Okay, much nicer. And then now you use parentheses 0.1, which is square, and then 1.1111, and then you cube like this. Okay, and then a plus. Okay, so we entered this one. Now we come to this one, which is 0.1. You cube, excuse. So you cube that one like this times okay, so the cube must have fourth power. So just left the fourth power there. So which means it is 1.1111. And then because the cube goes with the fourth power, like this, plus. Right, let's just continue and see what we have. Right, so we have here 0.1, you close, and then it is raised to what? The fourth power. Right, so then you have times. right, and then you have the 1.1111. So you have the fifth power. So we get the answer. Okay, so this is the answer. And now this is the estimate at the next step at 0.2. But obviously we have got the answer for 0.1, but this one is at 0.2. So what do we need then? Right, so what we need at this point is to write down the estimate here. So we have therefore that this one is what we got. And what did you get? Okay, I'm just going to write what we got. It's 1.24, 1.2499 6477. Okay, this is the answer that we got. But what is the meaning of these? Well, it means therefore that we are dealing with the Y2, but it is an estimate of the next step 0.2 because we have 0.1, and it means therefore honestly is an approximate value because there is a truncation error between this one and the most exact excuse me, and the most exact value obtained by using the exact solution. But this one is merely an estimate of the answer. So we continue to solve more problems and to look at many other things that we need to do here. Now, we continue to answer more questions. So let's reflect quickly. We have solved this problem in detail. We have got the answers to this one, but let's just reflect and see what actually we had to do. Right, use the fourth order. So we used the fourth order Taylor method with delta x equals 0.1 to solve the differential equation dy dx equals y squared. Obviously, going with y0 equals 1, it's x equals 0.1 and x equals 0.2. So we have obviously solved, because we have to solve this differential equation at 2 points. We have solved it at 0.1, we got the estimate. We solved it at 0.2 and we got the estimate. Okay, so this was the question. And the beauty of this module is the questions are with a good amount of marks. I mean, this here was worth in November, right? Was worth lots of marks. I'll just review now because I'm having the paper with me here. I will show it on the screen, but yeah, right. It was worth 7 marks. So it was worth 7 marks, or very rich in marks, this paper here. Okay, so if a student could do this, they therefore could walk away with those marks. Okay, the next question. All right, so here is the next question. The next question is question 1B. Let me just write that one down. Right, it's still from the same paper of November last year, but it is question 1B. Right, so question 1B focuses on a couple of things. And here comes the actual question. Use the method, use the modified Euler method with delta t. Okay, now we are just changing the variable from x to t. And with 2 corrections. Right, two corrections. And the two corrections mean that there is one correction and then there is one recorrection. Right, like so. And this is per step to find x at 1 and y at 1. Okay, so it's the same as the previous one in the sense of now you just need to get two answers there. Okay, right. For the initial value problem, right, for the value, initial value problem, like so. So which means therefore that dx dt is t plus x minus y. X at 0 is 1. dy dt equals y minus x squared. Right, and then you have y at 0 is 0, like this. Okay, so this is the question that appeared in November. Okay, now let us see what actually had to be done here. But I would like to first elaborate on the details that surround this here. Right, so there are specific formulae that we use, and we're going to cite the formulas that we use here. What are the formulas that we use? The formulas are as follows. For the modified Euler, there are formulas for the predictor corrector. So, I want us to give the two formulas a fair amount of attention right now. There's what we call the predictor. YP, which is the same as YI, plus HF of XI, YI, like so. Okay, there's only one formula for the predictor for the modified Euler, but obviously for the corrector and recorrection, we have two formulas. Right, the corrector. How does the corrector work? Right, the corrector works with the first correction. So YC1 is YI plus 1 half H, 1 half H, and it is F of XI, XI, YI, okay, plus F of XI plus H. Right, so this one here is going to be XI plus H. Then you put the Y predictor here. Then you close. Okay, that is the first correction. Then the second correction is seen as YI plus 1, which is YI plus H. And then we have XI, YI plus, then you have XI plus H, and then you have Y C1. So here you put the first corrector value, like so. And this is the case. And these are the formulas that we're going to use. But here we have two cases. So first we're going to solve the x one, and then we're going to solve the one for y. So it is like that. So let's continue to solve this problem. So to solve this one, so you have, for example, dx dt, which is t plus x minus y, x at 0 equals y. Okay, so this one here can call it anything. So I'm going to call it something. Okay, let's call this one G. Okay. And then now, how many variables are here? Because with the, normally we call it, okay, I'm going to write the other one below. Like this one is dy dt. And it is y minus x squared. How many variables are here? Okay, so like normally dy dt, you call it f. And then it becomes the variables themselves that are involved. So there is a t, there is x, and there is y. So there's t, x, y. Different from the former because it had only like x and y. And there were no other variables that we introduced. Right, so now we come to this one for the G. So there's a T, there's an X, and there is a Y, like this. Okay, there's a T, there's an X, there's a Y. But now the T and the X, you can interchange them, but normally X stays closer to X. Yeah, X stays closer to Y. So normally we say it's an XY uh, point. And then also here you'd have the X and the Y, but with the T. So we just maintain the order. Right. So with that said here, this one is X at 0. It's exactly 1. And then you have Y at 0. It's exactly 1, 0. Okay, it's 0 in the question paper. Okay, so we have introduced the notations, and then now we just need to get the actual answers. In getting the actual answers, we need to do something about this. What do we need to do? Right, so we need to consider the predictor first. Let's look at YP. YP is YI plus H. Okay, now we choose which one to start with. Maybe we start with the G, okay, because it's the first one. We could have called it F, but it's okay, we call it G. But the minute we put it into this, then we must introduce the subscripts here. So we're going to introduce the I's there. So which means, therefore, you shall have like a TI, XI, YI, and then now we have the X0 is 1. Okay, so we continue. Okay, for the predictor, we're going to get the first thing. So to get the predictor first, we agree that we have um, the variable here is an x. The variable here is an x. So an x is a function of t. And that means either way here, the implication is that x0 is 1, but x is a function of t, so that t0 is the argument. Okay. With that said, it means we can write here x. xp is the same as xi plus hgti xi yi. Okay. So which means therefore you have xp is xi plus hg of ti xi yi, and we have that x0 is 1, and then t0 is 0. And these are summarized by saying x at 0 is 1. Okay, obviously at this point we have x0. We have x0. And now having x0, we're going to continue and get to the first thing we need. Okay, so what then do we need for the predictor? We have already got x0, so we need x1. We've already got x0, so we need x1. Right, so getting x1, we proceed as follows. So this sort of becomes the difference equation for the modified Euler, for the Euler method. Right, so now um, I've just written the yp there, but it can be written as yi plus 1, and I'm just going to write that variant form of this particular equation for that. So these can also be written as this, which is going to make things a bit more colloquial. Yi plus 1 predictor, which is xi plus hg of xi ti, then you have yi, then you have x0, 1, you have t0, 0, you have x0, 1, like so. Okay, so we can write it this way, but this allows us to see, this presentation allows us, this is what is there in the memos of this module, but now we can write it like this to allow us to see exactly that we are getting x1p, which is exactly the same as x0 plus hg of t0 x0 y0. Right, so which means x1p is the same as x0. What is x0? It is 1. What is the h? Right, so the h for this one is in the question. They've written the h. Use the modified order with delta t equals 1. So this is sort of the change now. The change is 1. So is our h. So in other words, we continue here using our h, which is delta t equals 1. So here we're going to use 1, then g. Okay, g becomes this. So it's t plus x minus y. T plus x minus y. Now is 0, 0, 0, according to this. Okay, because we chose the g to be the dx dt. Okay, so that's fine. And then now you have x1p equals 1 plus What is T0? T0 is 0. What is X0? Is 1. Y is 0. What is Y0? Right, okay, we can see here. This one is like saying Y0 is 0, and then T0 is the argument inside, which is 0. So Y0 is 0. So X0 is 1, Y0 is 0. And then now we are able to get to X1P, which is exactly this. So this is 1 plus 1. And 1 plus 1, because this is 1 plus 1, which is 2. Okay, so we have exactly the predictor. Right, after we have got the predictor, we need to get the corresponding corrector. Right, so to get the corresponding corrector, what do we do? Right, so we need to use the corrector relation. What is the corrector relation? So we use the first corrector, but this first corrector must be written in terms of the X notation for the XY kind of problem. So we're going to use the X notation. So we continue with that. Right. So what are we able to get here? So it means that you need the X. So um, X I plus 1, X I plus 1 plus, right, I plus 1. Okay. Right. Let me write it as I plus 1. Corrector 1. Okay, you can write it as just only XC1. Right, YC1 is what I wrote earlier. So this is XI plus 1 half H, and then it becomes G. Right, so G of TI XI. Want to just get the difference equation for this one? YI, and then plus G of the following. Right, G of the following. G of TI XI. Okay, need to make a change here. Okay, because there are 3 arguments, you'll have to add the H to each of the yeah, you need to add the H to the T. Right, so you're gonna add this one to, and add here, you're gonna add H, or you can add delta T to this. And then here you're gonna have XI, you're gonna add H to it. And then now this one, you're gonna put the predictor, which is, you can just put XP. Okay, or you can put X1 comma P. All right. Now what is the meaning of this? This one is XI plus 1. Okay, now let's just substitute this one. So we getting the first corrector, or is X1 C1. Okay, so if it's X1 C1, it occurs at at I equals 0. So this is 0, 1H, and therefore this is G of T0, and X0, Y0 plus G of T0 plus H, and then you have X0 plus H, and then here, as I said, you can write something like so. Okay. Oh, just XP. Okay, I used the X1 comma P before, so it can be used. Right, now let us get the answer to this now. The first corrector, and then we shall do the correction. And then now this is about X, and then we do the same thing about Y. Okay. Now let's just continue. So which means X1, comma 1. What is X0? Right, we know that X0 is 1. X0 is 1. So we substitute a 1 here plus 1 half. What is the H? Okay, we have been given the delta H is 1 in this problem. Okay, delta H is 1 in the problem, so we're going to put it as 1. We're going to put it as 1. Okay, so delta H is 1. Right, so you continue. You put a 1. What is G? What is G? Okay, now this G, you can just plug in everything. Um, the G is T plus X minus Y. T plus X minus Y. Minus Y. T plus X minus Y. T plus X minus Y. Okay, plus. Then, oops. Uh-huh. The corrector. Right. Yeah, it's fine like this. It's average. Okay, so it's okay. See the first corrector. Okay, it's okay. But obviously with the first corrector like this, we're gonna do the same thing. So it's gonna be the T0 plus H, which is like T0, and then X0, which is X0 plus H. Okay, and then minus Y0. Minus this. So it's gonna be minus this. So it's gonna be minus X1P. Like so. Okay. The variables and so you can play around with these as you wish. So it's exactly 1/2 1. What is T0? It's 0. T0 is 0 and X0 is 1. T0 is 0, X0 is 1. What is Y0? Y0 is 0. Y0 is Y0 is 0 and T0 is 0. See? Y0 is 0. Plus now T0 is 0. Now the H is 1. X0 is 0. No, X0 is 1. You just need to remember there. So we know that X0 is 1. Okay. So we're here. Yeah, X0 is 1. Then H is 1. And then what is X1 comma P? It's 2. It's 2. Okay, let me just make sure. T0 is 0, X0 is 1, Y0 is 0, T0 is 0, H is 1, X0 is 1, H is 1, X is 2. So, which means the first corrector is 1 plus 1/2. So what is this? This is 1, 2, 3, 4 minus 2. 4 minus 2 is 2, and then this is exactly 2 because it's 1 plus 1. Right. Interesting. Interesting that it's not, it's just the same. So then we need to do a recorrection. Obviously, we ordered to do a recorrection, but it's very interesting that the predictor and the corrector are the same value. Yet this one is 2, and this is also 2. You can see here is 1 plus 1, 2, 3, 4. Anyhow, continue. Let's do the recorrection. So the recorrection, we just written the formula, so we continue with it. What do we do with the recorrection? And the recorrection, here it is. So it is yi plus 1, which is yi plus 1 half h. Okay. fxiyi. And then you have xi plus h. yc1. Okay. Yes, we are here. Okay, we continue. Okay, remember we are still dealing with the x here. So yeah, we're still dealing with the x. So let's continue with the x. What do we have? So which means therefore this is going to be like x I plus 1 recorrection, and then this is xi 1 half h. Okay, we chose g, and then it's going to be ti xi yi plus g, and then it is ti plus h, xi plus h. Okay, and then now you need to just take the previous one. So you must take x. Okay, it's like a y, but we take the previous step of, so we take this one. So we're gonna take x1 comma c1. x1 comma c1. So this one is xi plus 1. Okay, let's just get the x1 here. So which means therefore you're gonna get x1, x0, which is g of t0, x0, y0, and then this is t0 plus h, x0 plus h, x1, like this. Okay. So what is then the answer to this? Okay, x0 is 1. Okay, but before I plug in the x0s, let's just put the explicit functions of this. So now you then have here x0 plus 1h. And then now, what is the g part? So, right. What is g? Okay, g is t0 plus x0 minus y0. t0 plus x0 minus y0. So this is going to be t0 plus x0 minus y0. Okay, so we come here. This is t0 plus h plus x0 plus h. Okay, we're adding the like this one with this one, like t plus x, and then minus y. So it's gonna be minus x1 comma c1. So which means it is this. What is x0? Is 1. 1 half. H is 1. T0 is 0. X0 is 1. Y0 is 0. X0, T0 is 0. H is 1 plus x0 is 1, h is 1. Okay, now the x1 comma c1 was obtained before. The x1 comma c1 is 2. So which means x1 is that. So is 1 plus 1 half. So right, so this one is 1, 2, 3, 4. Okay, bizarre. Still 2. 1 plus 1 is 2. Okay, so you can see that we've done a correction and we have a recorrection as well in the first corrector and the recorrector are just the same value too. Okay, but obviously there are two equations here we need to solve. So we need to get used now using the second differential equation that's given in this problem. What is the second differential equation given in this problem? Right, so it is right. So yeah, it is dy dt. Oh, okay. Maybe let's put a comment here. So this one has given us the x1 gives us x at 1, which is, well, we take the answers as approximate here because these are not accurate answers, but it's approximately 2 because the accurate answer can be obtained if you like get the solve the differential equations and get the explicit solutions and then we can be able to get the accurate x1. But this one using the modified Euler are all estimates, and therefore they always carry what you call truncation errors, which arise as a result of the um, approximations. Okay, right, now let's look at the dy dx. And the dy dx now is y minus x squared, which is, we said that we call it f. So, okay, just call it t, because no, it's not, is dy dt, is dy dt. So this is exactly t, but then there is x and y that we must order like this. Okay, this is very important because the t comes from here. So it means that y, it's actually a function of, because we're differentiating y with respect to t, so y is a function of t, but there is also x as well. So in a sense, then the order in which these are just kept is very negligible, the x and the t. Right, so it's something to sort of take note of in a question like this. So make sure that you sort of understand that. And there's a lot more that obviously can be said about these kinds of relations. So yeah, just to take note of that exactly. Okay, we continue to solve this problem and to see what else can be done here as a matter of fact. Okay, as a matter of fact, what then do we do? Right, the couple of things that we do, and what we do here is to consider the predictor formula. And the predictor formula is the formula we have written. And we're going to use the predictor formula for this one, but also, okay, we know the initial conditions there. Okay, we saw them in the question, but the predictor. Okay, we can write the predictor in terms of y, but we're calling this f. So, which means that what this is here is the following. Is the following. Right. Predictor. So we're gonna say y predictor. Okay, yeah, I can write like that. Is yi plus h, and then you have the f. So it's gonna be ti xi yi. So okay, this is the predictor. Like I said, the predictor can also be written like this, which involves a bit more variables and symbols, a bit more symbols, but it creates um, a bit more meaning. All right, so, okay, we're dealing with the predictor now. Dealing with the predictor, we know a couple of things, like we know that x0 is 1 in this question. We know that x0 is 1. We know that y0 is 0. Okay, they're going to help us here, these things. I'm going to just use them. But at this point, we're interested in y1, p, which is y0 plus f t0, y0, no, x0 here. This is x0. Right, so it is exactly x0, and then this one is a y0, like this. Okay, so yeah, we're getting y1 predictor, and then now, okay, this is the explicit formula, but now y1 predictor can be seen, we're getting this is y0 plus h. What is f of these? Okay, the f notation is y minus x squared. So, which means that you're going to take the y minus x squared. The t does not feature at all. So it's going to be exactly y0 squared minus x0 squared, like this, like this. All right, so we're good. We're good. With this said, then we are in business because we can be able to um, y0 h, and then now you have y0 squared minus x0, like this. Right, so we have our notes as well. What are the notes? Are that x0 is 1, and then y0 is 0. Okay, and these both mean t0 is 0 being the argument in there. Okay, what is this? Okay, there's something I want to just mention here because these problems themselves are sort of a little bit unpopular in this module. But these are functions themselves, and you have variables which are dependent and independent. And I think that it's very important to understand that the dx dt notation, okay, I mean dx dt, all right, and the dy dt, why have they been written sort of like this? Because we have these variables, just a look into the variables themselves and the interplay here. Okay. Um, we continue. Okay, all right. I was saying that why are these dx dt, dy dt in the original questions? They are this way because of the fact that it means a couple of things. It means that ideally x is a function of t, but it also means that y is a function of t, like this. Okay. Okay, because it's very important to sort of have it, because now there are variables these guys are playing with in these particular questions. But because it's dx dt, it means that x itself is a function of one variable, and y is also a function of one variable. Okay, I'm just having this discussion because it's a very important one. So it means if you have the f, all right, so you continue. Okay, now what is this? What is the meaning of this here? This thing we've written here, I'm just going to squeeze something here. It means f has a t here, but you have x of t and then y of t. Okay, because there are just too many variables that the examiner has just thrown into this question. So it's very popular with the modified Euler. But it means this. This is what we have. It means that x is a function of t and y is a function of t. But now the y being a function of t, you differentiate y with respect to t. But wherever x features, x itself is a function of t. All right. Okay. Right. Three variables, x, y, and t. That's the point I'm trying to. In which case, none of which is quite a constant because uh, the x and y are dependent variables and t is an independent variable because it depends on x and y depend on t, and t is independent of any of them. Okay, all right, so we're back. Now I want us to continue with this. Now it means therefore for the first predictor here, what is y0? Okay, y0, y0. That's what it means. And then there is h. H is 1 for this problem. Okay, H in this problem is like delta T equals 1. So what is Y0? Y0 is 0. What is X0? X0 is 1. Yeah, X0. Okay, because this is X0 is 1. Then the inside is like T0 because X is the function of T. Right, so you have this. Okay, Y and this. Okay, because now you have that. The predictor 0 plus minus 1. Oh, um, which is minus 1, like this. Okay, so we're good. All right. Now we found the predictor, and then we must get the first corrector. So what is the formula for the first corrector? Right, so the formula for the first corrector is this one. So it is YC1, which is YI plus 1 half H F. F now will depend on TI, XI, YI. So plus which is ti plus h, xi plus h, then you're going to put y predictor. Okay, obviously the predictor we're talking about is this one, y comma p, anyhow. So let's just continue. Right, so writing things out, yc1, which is yi plus, then what do we have here? Okay, I want us to just write out the explicit formulas from the thing, from the given differential equation. So because f is y minus x squared, just y minus x squared. So it must be y minus x squared. There's no t there. So which means that it must be yi minus xi squared. There's no t. Okay, and then it is y minus x squared. There's no t. So it's going to be yp minus xi plus h. Right, so xi plus h. And then the xi plus h is squared. Okay, like so. Okay, now we good, but yeah, I mean, we write things like this, but as we said, this one is used to obtain the, so it has the yi plus 1 understanding here. So you have this one plus that, and then yi minus xi squared plus yp minus xi plus h. You have that. So, right, so you have this. So, okay, right, so now we're getting y1 because we have y0. Y1 corrector, so which means is y first corrector. It means it is y0 plus half h, and then it is y0 x0 squared plus, and then it is a yp minus x0 plus h squared. Okay, so okay, now which means y comma c1, y0 we've seen it is 0. H is like delta t, which is 1 in this question. Y0 is 0, x0 is 1, and then you have y predictor. It's y comma p, which is minus 1. Like so, minus, what is x0? Is 1 plus, what is h? Is 1. You square this. So y comma c1, which is 0. And then here you have 1/2. So now you have, okay, minus 1 squared, whatever. Need to just make sure that the square is clear so that somebody cannot square the negative, because the square is on the x naught. So that now you have like minus 1, which is minus 2 here. Okay, you can just write that one. Okay. The other thing, then minus 1, which is minus 2. Minus 2, and then this one is 1 plus 1, which is 2, which is minus 2 squared, minus 4. Like this. Okay. So what is this? This is minus 6, which gives us minus 3. So which means that the first corrector is minus 3, and then we need to get the second corrector. Right, the formula for the second corrector is as follows. Right, so the formula for the second corrector is yi plus 1. Okay, we write it like that for the corrector. But now, what I wrote before is what I'm going to write now for the corrector is sort of the standard one that is available in the memos for this course is 1/2, and then it is f. Okay, I'm just going to write the one of two variables here because it's the most popular. And then this question is a bit more variables. So has t changing, but also x is the function of the other, etc., etc. So right, so you have this one, which is xi plus h, and then it is yc1. Okay, so once again, what are we attempting to do now, and what is this formula for? So this formula here is for the most famous um recorrection. Right, is for the most famous recorrection. Okay, so it's a recorrection, it uses the first correction. Right, so now we are here, and what do we how to use this formula? We manipulate it. But now this formula is for two variables. This problem has a bit more variables, so we need to sort of adapt this formula, and we're going to adapt it for the y dy dt formula. So it's my y we're maintaining here, dy dt is y we're maintaining, but this one is f. F is a function of three variables, so it is t and then x I. You can even write this one here, and then yi is each one of these the x and the y are functions of the independent variable t. So you have um, this, so you have t here. Okay, so now you have exactly the same, but it's going to be ti, and then you add a h to it, and then you have xi. Okay, so now this is very interesting. So yeah, to save space, I'm gonna just write xi plus h, then you have yc1, like so. Okay, now what is all these? What is all these? Right, so we just need to write the explicit formula for the f, but we know very well the explicit formula for the f because f txy is y minus x squared, just y minus x squared. So it means it's the y minus x squared, y argument minus the x squared argument, so we do that. So, which means we have the following. We have the following. Okay. So you have 1/2. Okay. So h, this one. And then now, you have this. All right. Now it's this one is y minus x squared. Excuse. Yeah, this is y minus x squared. So you substitute that. So y is gonna be y I minus x I squared plus, and then here is gonna be y. So it's gonna be yc1 minus xi plus h squared. Okay. So what do we get out of this? Okay, we continue, please, to finish up quickly. Okay, once we get this one is the difference equation we need for the recorrection, but we shall get y1. So when I is 0. Right. So getting a y1, it means y0 plus 1/2 y0 minus x0 squared, yc1 minus x0 plus h squared. So you have y0 and 1/2 h. You have y0 and then okay minus x naught. Okay, I'm just writing this out so that we can just substitute the rest of the things. Plus yc1 minus um x0 plus h. Right, you have this. So now we continue. What is this? Okay, what is y0? Y0 is 0. Okay, delta t, which is the same as h, is 1 in this question, so is 1 here. Y0 is 0. What is x0? It is 1. What is yc1? Y comma c1, I wrote it. Y1 comma c1 is minus 3. Minus 3. Minus into x0 is 1. And then h is 1 in this question. Okay. And then you square this and you close like this. So which means y1 is 1/2. Okay, so we have this. Right, so this one is -1 minus 3, which is minus 4. -1 minus 3, which is minus 4, minus 1 plus 1 is 2, which is 4 when you square it. Okay, this is what we get. And then this is -8, half of it is -4. Let's see what we've done so far. So we've done the corrector and then the correction, the first correction, and we've done a recorrection. Right, so what is the meaning of this recorrection? Well, it means that this y1 now gives an estimate of the value of the function at 1, which is approximately -4. But obviously, it is just what we have got. But also, this one also gives a value of the function, so which means y1 at c1 is approximately -3. No. So it's -2, -4, -2, -4, -6, -3. Yeah. So y1 it's approximately -3 for the first correction, and then this one now for the recorrection. So we have got -4. Obviously that is what we have here. Right, right. Now, what are the answers to this question? So we've got the answers to this question in full, and as it came in November, right? Use the modified Euler method with delta t equals 1, and with 2 corrections, 1 correction, 1 recorrection per step, to find x1 and y of 1 for the initial value problem. Here is the initial value problem with x0 equals 1 and y0 equals 0. Right, so we need to find two things, the answers. We need to find x1 and y1, and we've already got those. So, and we're going to mention that. To mention here, hence, so we can be able to get x1 is approximately something, and y1 is approximately something. Let us see what we have. Okay, we've already got those, the x. What did you get the x to be? Okay, so which means the x is approximately 2 because the first correction was 2 and also the recorrection became 2 for this problem. So we're going to have that this became 2 here. And then now for the y, we've already got the answer, which is approximately -4. So is approximately -4 there. So we have the answer for this problem. Right, so now we look at the next question that we need to do. Let me just pick a nice question that we're going to do from this exam, the same exam paper of November 2023. We're giving it some good, very good amount of focus. It is my plan that we must be able to finish this paper tomorrow and do other papers quickly. I'll put a plan for that in place. Right, so here is again November 2023. Right, and then now we are looking at this question, but it is recorded as question 3 in this paper. All right, so now we are given the following. It's a very nice little question, but it came in this exam. Right, given the power series, we've done a lot of this, and I'm sure that it should be very easy to do at the moment. Given the power series f of x equals 1 minus x cubed, and the chair by Chef polynomials t0 of x is 1, t1 of x is x, t2 of x is 2x squared minus 1, t3 of x is 4x cubed minus 3x, and then now you have t4, which is 8x to the 4th power minus 8x squared plus 1. And the question says you need to economize. Okay, economize. Right, you need to economize the power series. You need to economize the power series f of x twice. Right, so now, how is this done? How is this done? Okay, let's analyze together how this is done. So now, the couple of things here that we need to do. The solution to this. How do we economize the power series? Okay, to economize the power series, we just reduce the order. That is all. So given the power series, this one, and the chef by chef polynomials, like your T0 is 1, your T1 is X, your T2 is this, right. So you need to economize it twice. And to economize it twice, we look at what we did before and we attempt to employ this. I want us to look at recall one discussion we had here about economizing power series. But economizing power series by reducing the highest degree. How do we reduce the highest degree? Right, so we take note of this. Right, so reducing the highest degree and how we do that as well. So it's something that we're gonna just explore right now in relation to what we did before. And we shall be in a position to get these most certainly right. And let's just analyze these together at the moment. Right, so the solution is as follows. Right, the solution is as follows. Right. So the couple of things, obviously, that remain extremely important for us to sort of economize these power series. So we note that f of x. What did I say? I said it's part A. Yeah, it's okay. Right. So f of x is the same as what? Okay, is the same as this one. 1 minus x cubed. 1 minus x cubed. And then now we look at the highest power of this, and we get a new function we call f star. Right, there's a new function we call f star. So okay. Um okay, now okay. Okay, is it half? Let's write T4. Right, so there's T4. T4 is 8x to the fourth power. Yeah. T4x is 8x to the fourth power minus 8x squared plus 1. Okay. All right. Now let's compare this very, very carefully. And then I want to write T3 as well. Okay, so let me just remove this. Let's write T3. Want to see what algebra to perform here. What algebraic manipulation to perform. Okay, so T3 is, look at the degrees, 4x cubed minus 3x. Right, so it's 4x cubed minus 3x. And then now there is T2, which is 2x squared minus 1. Trying to really analyze all of them. T2 of x, which is exactly the same as 2x squared minus 1. And then there is T1x, which is x. Right, T1x, which is x. And then T0x, which is 1. What? Yeah, 1. Okay, these are the Chebyshev polynomials. But now let's analyze this together and see what we need to do here, because we need to manipulate this. But if you look at the we need to given the power series, this one, we need to economize it twice. Okay, but the first, to economize this, we must remove the highest degree. So we need to remove x cubed. But to remove x cubed, we must use the polynomial that is having the highest degree x cubed, which is T3. So now we are in a good position. So which means that we're going to have T f of x. No, f star. F star of x. Right, which means f star of x is the difference, you know. So it is f of x, or the sum. It is f of x, which is this one. And then now, which is having the highest degree 3, and then now the highest degree 3 appears in T3. So what do? We add these up, because this one, this f of x is having minus x cubed. But we must therefore add x cubed. So we must add 1/4 of T3 of x, because it's only 1/4 that is going to eliminate the 4, making it a 1 here. What is f of x? 1 minus x cubed plus 1/4. T3, which is 4x cubed minus 3x. So, which means 1 minus x cubed plus x cubed minus 3 over 4x. Right, so, okay, we've been able to economize because the highest degree is gone, because minus x cubed plus x cubed is actually equal to what? Is 0. And then we have 1 minus x minus 3 over 4x. So, okay, it's the f star. So, which means that f asterisk of x is the same as 1 minus x minus 1 minus x minus 3 over 4x. Okay, so this is what we're getting for the f star of x. And then we're sort of good. All right, but we must economize it twice. Okay, let me see. All right, so this is awesome stuff, because now we have just the 2 linear degrees here, degree 1 terms. So you can just add this up. They are like terms. So you have f star of x is the same error. So this one is minus 4 over 4, which is minus 7x over 4, like this. Okay, we continue. Okay, yeah, we continue. But we must economize it again, because now this one is the second degree, is rather the first degree, linear. So it means, therefore, we must continue with the process now. So to economize this now, we must remove the power, the highest power, which is power 1 of x. So we must remove the x term. And to remove the x term now, it's very, very interesting. So okay, we analyze the polynomials in the chef by chef relation, right? So you need to now see that we need to use a polynomial that has highest degree x, because the others are not going to help. Like this one has an x term, but if we use it, want to eliminate x, it's going to introduce a high degree term. So we can only use this one, T1x. Right, but we need to use it very cautiously, because now if we use the T1x, which is x, we need to introduce, we'll develop another function, f double star. So thus we have f double star of x, which is f star of x, okay, which is this, but we must remove this using this. So which means that we can just add the plus 7 out of 4 of x. Okay, because if you add this to this, then it goes. All right, so, okay, this is only star, it's not a prime. So now what is the meaning of this? So the f star of x is 1 minus 7 that, and then plus, and then, yeah, this one, okay, right. So, yeah, that's what I meant here, but let me just write more in a more popular manner. So it's T1 of x. It's T1 of x, which is that. So obviously it becomes 7 out of 4 of x. Right. So in the end, this what happens is therefore that this one cancels out, leaving us with a 1. Oh, okay. Right. It leaves us with a 1. And hence we have that with the economized twice, relation is 1. So f double asterisk of that is 1. So we continue. All right. So we had to economize it twice, and this is the answer. What is the answer? The answer is this. So we had to economize the power series twice, and that was the question. Right. So we are concluding our discussion now for today. Right. So given the power series this and the shape by shape polynomials is given this power series, you need to economize this power series using the shape by shape polynomials. These shape by shape polynomials are 5 of them. There are 5 of them, including the 0th polynomial, and we therefore have economized the power series. Obviously, removing first the cubic one, and after we removed the cubic one, we're left with linear, and then we just remove the linear, and then we are left with a constant term. This is the answer, and I think that for today it is wonderful that we've had this discussion. We are just on the exam of November 2023, and we continue with the same exam paper tomorrow. Look at how we can expedite processes, in particular when we do iterations and things there, to make sure we try to cut out time wastage, but also quickly finish the paper so that we can see other papers as well. We're looking at the November 2023 paper at the moment. Right, I think that for today is pretty enough. I must be able to see you tomorrow at 4 p.m. I understand that 4 p.m. might sound a little bit late, but yeah, it works best because you can do a couple of other things before and then spare time for the discussion later on.